So we're going to quickly talk about solving two-step equations. These equations come in basically just two forms. One where there's no distribution that needs to be done, and the other where there is some distribution that needs to be done. These could be represented in a couple different ways, but I think if we just think about what would happen if we ignored the side with the least amount of stuff. If we ignored that side just for a moment, and we said, how do we evaluate this if x equals, I don't know, 1? In this case, we go 8 times 1, which is 8, minus 21, which is negative 13, right? And so the last thing we would do is minus 21. So that means it's the first thing we're going to undo. The last thing we're going to do if we evaluate it is the first thing that we undo. So here's how we do that. We're going to undo the negative 21 by adding 21 to both sides, right? And then we do the math and we go 3 and 21 is 24, is 8x. Negative 21 plus 21, that's 0. That's done. So now we're down to the one-step equation, which we've practiced a lot at this point. So we're going to divide both sides by 8, and we get x equals 3, or 3 equals x. And so at this point, we can plug back in this 3 up here and go 24 minus 21 is 3. Great. Problem solved. All right. So remember what I said before. The last thing that we would do if we were evaluating the expression is the first thing that we will undo. So if we were to ignore this side, and we were to say x is 3, for instance, we would do 3 plus 5 and make 8. Then lastly, we would multiply by 2 and get 16. So because the last thing we would do is multiply by 2, it's the first thing we're going to undo. So in this case, we're going to divide both sides by 2. That's how you undo multiplication. And when we do that, we get x plus 5 is negative 18 divided by 2 is negative 9. Now we're down to a one-step equation. And like before, we've done this a lot. So we're going to subtract 5 from both sides. And we get x is negative 24. So remember, the last thing we would do to evaluate an expression is the first thing we will undo in order to solve it algebraically. Okay, thanks. Bye.